let's start. Rewriting 15-year-old code. In case you're wondering about this picture, why I chose it, it's because old code tends to blow up in your face, or sometimes you secretly wish you could do that to your code, just start over, nuke it. It's working, yeah. So what I do, I'm Filina, I do project rescue, I work with legacy code a lot, I develop, I speak at conferences, I also give private workshops, and I come from Canada, so it took me about 16 hours to get here. Let's say you inherited a 10-year-old code base, or maybe it was a 15-year-old code base, or maybe it was even a 17-year-old code base. And here's the secret. Code does not age like wine. I mean, on its own, it doesn't actually age just by sitting there. It still works. But when you come back to it much later, you see how dated it is, and the approaches that we used in the past no longer apply. So what was the web like when this code was written, the 17-year-old code was written? So back in 2000, the web was 600 pixels wide, for real. So this is Yahoo, for those who weren't around. And what else happened in 2000? Well, obviously we had the Y2K bug. So for those who were not into computers at that time, the Y2K bug is when we stored dates as the years as only 2 digits. And in the year 2000, it became a problem for sorting, doing a difference on the dates. So all sorts of problems occurred, especially in the financial sector. Internet Explorer 5 was hot. So I know how people curse Internet Explorer 6 and it's almost dead, but we had to deal with Internet Explorer 5. ICQ was only starting to be cool. And if you could do rounded corners, you were really the cool kid on the block. If you remember, back then we didn't have CSS, rounded borders. We had to do a table with 9 cells and actually draw things by hand. It was very messy. So your code was written around that time. So it is normal that, especially in the web, that it wasn't following today's clean code standards. So all of these things that we've been talking about for the last almost 20 years, it didn't quite apply back then. The web was relatively new, and so were the developers who got into it. So it was written the way it was written, and I get a new legacy project every few weeks or so. Not recently because I took a job, but I've been a consultant for about 15 years before that. And I want to share some stories and some advice on how to deal with that kind of code. So let's talk about code smells. So how do you know that you're dealing with a legacy code base? And the thing about legacy, it doesn't necessarily mean that it's an old code base. It's a term that has been extended to include and we call it legacy by design, which means that something that has been, a project that has been delivered maybe a month ago already looks like something out of the year 2000, simply because the developers who coded that, weren't quite sure what they were doing. Maybe they were trying a new technology, maybe they just started coding, or maybe they just don't care. So how do you know? So I'm going to show some examples in PHP, but the advice applies to almost every other language. I'm going to talk more generic stuff. So mixed concerns means that you put a lot of stuff into the same file that you should not mix. So for example, when you access the database, that should be handled separately from, say, your business logic. So here we query something, we iterate, we add to the total, and then we output things, all in the same file. That's what I had to deal with in the beginning. And when I started working with PHP, it was still PHP 3, and it wasn't even object-oriented at the time. So it was even worse than it is today. At least today, people are using frameworks and stuff. So usually in code like that, there's no routing mechanism. So basically, files are just structured inside folders. So if you want to go to, say, admin purchases, you would actually have a folder called admin and inside a file called purchases.php. So it was pretty messy. There wasn't much you could do with that. You would also find poorly named variables. That is just a general problem that people have is try to write short variables. Of course, $I in a loop makes sense because it's very clear what it does, but $A doesn't mean much, or array for that matter. Like what is inside the array? I guess it's an array, but of what? Item 1, 2, 3. Once you start appending numbers to your variable name, it means that you're not quite sure what you're doing, or you don't care about expressing what it is you're doing. Or just temp item. Okay, it's a temporary item, but to do what? Just random name. I've seen a code base that was more than 15 years ago. It was a code base where people would just name their variables with a letter, and at some point they ran out of letters, and with the Z they started adding numbers. So you had Z1, Z2, Z3, Z45. They just kept going. Like at no point did they realize maybe we should come up with something better now. They just kept going in that direction, all the way. Global functions and constants. So in PHP and other scripting languages, you can include other files. So what people would do often is just include a bunch of functions that are readily available. It's not really a good approach, because then you can include files that include other files, so tracing what's happening becomes really hard, and then you get sometimes collisions, like you're trying to import a file but you can't because that file imports some other file and it collides with another function name that you're using, and can become a mess very quickly. The equivalent of that, I would say, is abuse of static methods. So importing something in the global namespace, or just namespace your methods by using a class but not actually any instances, makes little sense. I'm not against static methods in general, but some people who use only that in their code base defies the whole purpose of using an object-oriented language. And of course, the beautiful dev mode. So this is a constant. So it's a constant that's declared somewhere, and it can be a problem, especially when paired with the includes, because let's say you include a configuration file that sets the dev mode, but sometimes people refactor things and then they have like a separate configuration file. So some pages would basically include one config and another page would include another config. So between different pages you get different mode, and you're not always fully aware of that, and that can be a problem. And it can get even worse. What happened with a project I did about 5 or 6 years ago, not only did they have different values for dev mode, but they had another variable. So instead of this being like a sort of global thing, global state where, okay, if we're in dev mode, we're not going to charge real credit cards. No, they went and they created a separate variable, a separate constant for that, called payment gateway test mode. So if you're not aware of that, and you're just, yeah, I'm in dev mode, right? So no real credit card transactions should go through. Well, no. Now you have that transaction flag, which is also different based on the script you include. So you could accidentally charge a lot of credit cards, and it's something that happened. So we had to refund people, apologize, and stuff like that. It was a sort of an embarrassing mistake, let's say. So you have to be careful not to trust these constants. Like if you see something like that, don't assume that everything is just magically going to be sandboxed. You have to not make any assumptions and really look deep and make sure that before you are calling that script, nothing bad is going to happen. You have to look at them one by one. Inexplicable conditions. This is something I saw in an actual project. Even the numbers match. So not everything I show you is from actual projects. So there was this condition where it said, if order ID is greater than 20,117, use this SQL. Otherwise, use this other SQL. Then you wonder, what the hell happens at order 2117? What happened there? Like, did the database structure change? Did we start storing our orders somewhere else? Or did we keep the same tables, but some columns became deprecated? Now we're fetching data from elsewhere? Well, that's a problem, because If you now want to write new code for that and the database, the data that's being stored is not constant, it's not always stored in the same, using the same approach, then you can be in trouble, especially if you start making changes before you encounter that, because you look at the latest data, you know how to query it, and then you're missing all the old transactions for some reason in your stats. Then you wonder what's happening. And then hopefully you find this before, but if not, that's a big issue. So when you find something like this, normally I call that a weakness in the code, and it's usually time to refactor. So a way to refactor that, the cleanest way to refactor it would be probably to go and change migrate the old data to be compatible with the new data, so that you don't need that condition. You can just query everything the same way. Unfortunately, it can take some time. If you don't have the time to do it now, if you're not going to deal with that database really, if you just need to go and do a quick patch, at least bookmark this line, because when everything goes to hell, the answer will probably be in that line of code. So this if will hold the answer. Long methods. The code here doesn't matter. It's just like a very long method. So methods that extend for pages and pages, maybe they accept 20 arguments that are not even named. It's just unwieldy. So if you see something like that, you know you're dealing with legacy. And I'll show you an example of how you can fix that. When I get Codebase, the average legacy code file is between 3,000 and 6,000 lines of code. That's one file. Half of it is commented in case we need it for later, because who cares about Git? That's too hipster. We do it the old-fashioned way. We comment things out, and we append that backup 0.5 at the end, or new final, whatever you prefer, and then you end up with gazillions of files. And even method lengths are extremely big, like 800 lines of code in a single method. That's a lot. Personally, I try to keep mine under 10 lines as much as possible. If it's more than 10 lines, I refactor. Okay? It's easier to test, it's easier to debug that way. And abuse of helper classes, like I showed you earlier, you have like too many static methods. It's kind of hard to debug, because you can't really set like a proper state or anything. And sometimes no classes at all, just no classes. And have you seen code like that? Have you dealt with anything? I'd say about a third to a half, yeah? Okay, makes sense. Yeah, I share your pain, I'm sorry. But it gets easier over time. The Codebase itself had, so this is one project I had with 5,000 classes, 20,000 methods, just rounded up, and 1.5 million lines of application code that does not include the framework. It's actual application code. And it wasn't really a complex project. It could have been like a 1/100th of that very easily. I have no idea how they managed to get so many lines of code, but yeah, a lot of duplication also. And so this is quite commonplace in my line of work. And it seems to be very difficult or even impossible to refactor these projects. These big beasts, you look just at the counts of the lines of code, and you're like, no, I'm not touching this. This is going to be too complicated. But actually, it's not too bad. And with a good methodology and enough practice, you can do it. But before you start coding anything, before you start putting your axe into the code, you need to have a strategy. So the strategy, think of it like a house. If you want to move walls in the house, there are certain walls that you cannot move. Those are your constraints, because if you move these walls, everything will collapse. So you have to find, what things you can move and what things will remain. For example, if you cannot change the database schema, that's a constraint you'll have to deal with. So you'll probably do something like some sort of mapping. Whoa, I adjusted it too much. Some sort of mapping that you can, map on the old database, but use proper objects, or something cleaner for your code. So you don't have to have a one-to-one correspondence in the naming. You can standardize the naming. So if the column names in the old schema are all different, you can standardize that when you map. Okay, if this is always called a name, then it should remain name, for all other objects. So just reuse column names, or like I've seen 10 different ways of naming a timestamp. Like sometimes it's created at, created on, date created, timestamp, or time created. So it's just like you standardize that, and it makes it much easier for you later on to refactor that. Now, the other decision you have to make is, do you want to do a full rewrite or do you want to do a progressive rewrite? I would tell you that most of the time, and like more than 90% of the time, full rewrites fail. And there are many reasons for that. Because when you do a full rewrite, you don't really have any documentation, so you don't know how things are done. So by the time you learn how the code works, then you have to reverse engineer that. While you're doing that, you're not fixing bugs in the old code base, and it could take you 2 years to release the new version of the product, but by that time, the business might have changed, so now you still need to catch up on 2 years of changes. And during all that time, your client or employer is not getting any value out of it. So for two years, there's no ROI. It only comes much later. So it's a big investment that if a company is already running, is using the code base, they're not willing to make that investment. So if you do a progressive rewrite, and you can do you can monetize things immediately, like 40 hours, and you can start monetizing things, or maybe less if you're taking on small chunks to rewrite. You can rewrite by class if you have classes. You can rewrite by feature module, which is my preferred approach. Like I grab one big chunk out of the code and I rewrite that. So one of the things I did for clients was he had a billing module, which was doing all the recurring billing. It would calculate based on the usage, a bunch of criteria, refer to different tables for every single piece of thing that they would charge, and then they would send a bill. And that module had tons of bugs in it, so we just rewrote it because it was just using SQL queries, and it reached the limit of what SQL could do. They actually needed to grab the data and process it inside their code. They could no longer do some of the things they want to do just by SQL. So we had to rewrite it, we had no choice. And as we rewrote it, we made it more flexible, and it took about 40 hours to do. And the 40 hours were very easily monetized because the extra money they made, because there were no longer mistakes, within the first week was already more than what they invested in the rewrite. So it was easily monetized. And you can do things by HTTP call. When you do by HTTP call, it means that you would have to run code side by side, but the only thing you really have to worry about is just sharing the database, sharing the session, and just like if, like mostly for the web, you would do a mod rewrite to direct the request to another application. So you can change languages, you can change versions of the languages, different framework. You can like start building a completely new application on the side and just redirect the requests that have been rebuilt with the new application, which is much simpler than most people believe. People are generally just scared of trying these things because they think it's more complicated than that. But once you start doing it, it's pretty straightforward. But before you, so once you get the strategy, then you have to take some precautions. So we're not ready for the code yet. We have to do backups. And not just have a backup, but test the restoration of the backup. And I saw this on Twitter some years ago. Somebody called it the Schrodinger's backup. The backup both exists and does not exist until you try to restore it. Because, yeah, I mean, you have a file. It's roughly the size you would assume it would be. But when you try the restoration, it's maybe corrupted. Maybe something is missing. Like you dumped the database, but you forgot the views or the stored procedures, which have a tiny footprint, so it won't show on the file size, really. And you wouldn't know that until you try to restore, and you're like, oh, it's not there. And now all of my queries are failing because they depend on these stored procedure and on these views. So it's very important to backup, restore, make sure that your backup is actually there, valid, contains everything, and the code can still run after that. If you are going to do backup of the database, make sure to nullify or anonymize the sensitive data. And the way you do that is by replacing emails with some fake data, probably at example.com, so that even if you do send out emails, it's not going to go anywhere. So they're going to be rejected. So you cannot accidentally mail real clients, and you don't have that private data on your computer. If you do store credit cards in plain text, which does happen with some clients, they have like thousands of credit cards. You don't want that responsibility, by carrying it on your laptop. I mean, their servers, their responsibility, but if you start carrying it on your laptop and you don't encrypt your hard drive, you're going to have a problem. So just replace it with some of those test credit card numbers. So for example, Visa is 4 and then just ones, 15 ones. You can do that, and then even if you do try to process a transaction accidentally, it will just be it's a test card, so in production mode it will just get rejected. So you have an additional safety there when you anonymize the sensitive data. Other data, like other identifiable information, you can also replace. And there are some libraries you can download. There's all sorts of fakers that you can download that can just generate a first name and last name at random, so it's not real data. Right, and then of course you will need a staging server, because a lot of people don't have that still, where you want to simulate deployments, upgrades, any batch processes you want to run in the proper environment. Obviously, if you're going to make any changes to the code, you have to automate tests before you make the code changes. So it doesn't mean that you need to start with 100% code coverage before you can make any change, because that's ridiculous. If you have 1.5 million lines of application code, you probably don't have time to write tests for all of it. Just write the tests that make sense to assert the things you want to change and move from there. And also make a risk assessment. Don't be too optimistic. So, okay, you're going to change this. What are the associated risks? Okay, we could accidentally charge credit cards for an incorrect amount, things like that. So we want to take some sort of precautions. We want to assess that risk and see whether we want to take more precautions or fewer precautions. And when I say don't be too optimistic, that means that we tend to underestimate the risks, and also make sure that you account for side effects. Some of the side effects include, let's say you charge incorrectly a credit card. Well, now you have to fix a lot of data. You have to fix their statement. You have to find out, the transaction difference. You have to credit the difference for the transaction. You have to probably send an email explaining why you're crediting that amount. So there's a lot of there are many things you might need to do, and probably do a lot of more code if you do make a mistake. So account for those side effects, but then also evaluate, how much effort it takes to revert something. If the client tells you, well, it's not really a big problem, because if you make this mistake, it only takes me 10 seconds to fix it by hand, then of course you're not going to invest 40 hours taking some extra precautions if it only takes the person 10 seconds to fix. So sometimes you might also overestimate things. And of course, if you are going to try things against a database, don't just reverse engineer a database with data based on what you think it should be. There are a lot of surprises you will find, things that you might assume. For example, I had a project once where they were storing associations between users and accounts, like a many-to-many association. But what's funny is that they had what I believe to be a legacy column, because it didn't have too many results. The legacy column was account ID, so it was a foreign key. So I assumed that in the past, they associated an account with just, a user with just one account, but then they wanted users to have access to multiple accounts, and then they created the intermediate table. But in reality, they had this weird logic in the application where if the account is only associated with if the user is only associated with one account, then use the foreign key. If there's more than one, use the many-to-many relationship, which made absolutely no sense, and it crashed in production because we were not given access to the production database before the release day. So we had to go and fix things very quickly. So always require a real database dump, even if it's just a subset, because the garbage data that is there is going to bite you. You can never guess all the garbage that can be in there. So you have to have the real thing. And let me talk to you about a failed rewrite example. So somebody thought, hey, let's do a full rewrite without planning anything, without taking any precautions. Let's just go and dive straight into the code. So yeah, the project was moving from PHP 3 to PHP 5.6, which is a major move. First moving from procedural to object-oriented. And there are a lot of features in PHP 5.6 that did not exist even in 5.3. So, mixed concerns includes all over the place, ifs that concatenate SQL and then include other files that append to that SQL. It was really convoluted. So the previous rewrite attempt has failed and made things worse. Because where you once only had to understand the philosophy behind one bad coding practice, now you have two of them, right? So, at some point you sort of get the personality of the developer and where they were going with this. But once you have two ways of doing that, then it becomes hard because you don't know who wrote which part, and then you kind of have to deal with two different philosophies in the code. It's bad code, but it's still, there's still sort of an idea of how they want to structure the code, and you end up knowing that you familiarize yourself with the code and you can get a grip on it. But here it made things worse. There were folders of dead code that were not cleaned out and caused a bit of delay when refactoring, because you fix a bug and you're like, oh no, right, this is dead code, but I don't want to remove it because I'm not sure if it's still being used. And at the time we did not have good static analyzers, so it was very hard to tell whether it's actual dead code or not. Yeah, and there were classes, lots of classes, but just static functions, no instances. And what's interesting is there was a colleague, over 10 years ago, I worked at a company where we would receive code from other companies, from subcontractors, and integrate it into our platform. And we asked them explicitly to use object-oriented code. So they sent us the code, and there was a class, one class, and everything in it. And what my colleague said, he said, well, it is object-oriented programming. We have an object, we just need to orient it somewhere. Yeah, that joke really stuck. So the solution for that was to rewrite some of the more complex forms in Symfony. Symfony is a framework in PHP. And then we used mod rewrite for the concerned pages. So if the request is for that URL, redirect it to a different application that will handle it. And that was a very easy approach. And then the biggest module, the one I talked about, the billing, we rewrote it using OP. And we used a concept called design extraction, which I will cover in a minute. And that allowed us to have more flexible architecture. We started to have some automated tests because we wrote, of course, that module as OP. So yeah, the solution was actually pretty clean and did not take that much time. And I always say a new feature or any sort of iteration for refactoring should not take longer than a sprint. So when you do progressive rewrites, if it takes you more than a sprint, then it's probably you're taking on a chunk that's way too big. Start with something small. And the thing is, as you refactor smaller chunks, you can start reusing code, so when you take on something bigger, it's still going to be faster because you already have some building blocks to draw from. So the invoice calculation was rewritten in just under 40 hours. It was on both my flights to and from South Africa. I finished it because it was a 22-hour flight in each direction, roughly. So yeah, I just finished it on the plane. That was a sprint. Design extraction, something I mentioned. The reason we do that is because when you arrive into a legacy code base, there's generally no documentation. There are very few people who even know how things are supposed to work, but nobody really knows how they actually work or how things were implemented. And if you try to rewrite things one for one, you just look at the old code and you try to make it better, here, cleaner, you will be biased by how the code currently works. So what you rewrite is not actually going to be clean. You'll keep repeating the same mistakes most of the time. You'll reintroduce the same bugs, you'll reintroduce the same flaws. So the way we do that to avoid this code bias is we take the old code, and from that we create design documents. So you draw some diagrams, flowcharts, DFDs, ERDs, all of that. You create basically you create specification for the code, like go the other way around. Then what you do is you validate this documentation with whoever knows how things are supposed to be. Because the documentation is, although it's technical documentation, it still reflects how things are supposed to be. And not necessarily the how things work, not necessarily all the inner workings. You can have like decision trees, things like that you can always validate with a non-technical person. So you can clarify those business rules. And once you clarify that, then from that, you create new specification by incorporating the feedback. Somebody's going to say, well, no, I know how this works, but this is not how it's supposed to work. It's supposed to work like this and like that. So you incorporate that feedback, but you also create completely new design that is much cleaner, more adaptable, flexible, like just a better architecture overall. And from there, what you have now is an entirely new specification. So what you do, you ignore everything that came before it. You ignore the old code, you ignore the old design docs, and what you have is you need to write new code based on specification. So it's like almost a greenfield project. So you just go from there. And that way you can be sure that you do not have this bias. So it's very, very important to do things like that. And yeah, non-technical people can understand flowcharts, decision trees, entity relationship diagrams. They're actually pretty easy to understand for business people. So you can show it to them, you can discuss it, and before you know it, they're actually going to grab a pen and write something on top of it and say, no, this should be restructured that way. And this usually happens. Now that you have your plan, you can write new code, but sometimes you just want to fix bugs. And the way I usually say it is, if you touch legacy code, you have to improve the part that you're touching. And this way you always remove some of the technical debt. And you leave it in a state where if you made a mistake, you can go back, but now you have much cleaner code to deal with. You understand what it's doing. And not just because you wrote it, because you have to make it cleaner. And when you start fixing bugs, one of the things that usually bites is code duplication. There was a project where a bug was repeated more than 80 times. Like they literally copy-pasted the file 80 times and made tiny changes for each of the scenarios instead of generalizing. I couldn't imagine a developer thinking that was a good idea. I don't know what kind of time pressure they were under, but that was clearly not the way to go. And will bite you really hard, because if you fix a problem in one place and then somebody comes back to you and says, well, no, it's not fixed, I'm still seeing the bug. Oh, you're seeing it on another page that looks very much the same. Well, it's the same page, but it's just, it's loading a different file, and that file still contains the bug. So instead of fixing it 80 times, what you have to do is remove the code duplication. And just by removing that, I think I saved like 60,000 lines of code just by removing that. Just one template. Remove 60,000 lines of code, and now I have something that is maintainable, flexible. So instead of including a separate file for each of the views, I pointed all of the controllers to the same view and just passed different, common variables and just customized it based on that. So once you start fixing bugs, you want them gone for good. So make sure you remove those duplications. People don't always think about that, but it's very important to start looking for repetitions So grep is going to become your favorite tool. That's true. And you're going to have to learn regular expressions. I mean, it's helpful to know them regardless. They're not as intimidating as they appear. So the other thing is, how are you going to fix long methods? So let's say, a company came to me a couple of years ago and said, hey, we have this problem in our calculation, and they show me the method, it's 800 lines. I'm like, okay, I cannot possibly, like the cyclomatic complexity of that is through the roof. So writing unit tests for that just doesn't make any sense. I mean, it was, I don't even remember the cyclomatic complexity, but it means that you have to write possibly hundreds of unit tests just before you can start fixing it. So instead, and I later discovered that it was an actual thing. So method extraction was something I read in a book later by Martin Fowler. I'm like, hey, I invented that. No, I guess not. But I just independently discovered that and a lot of the things in that book. So what you do is you can extract well, in case of fixing bugs, you extract broken parts into their own methods. So once you narrow down to where the bug is, it's usually a block of 10 lines of code, you grab that and you create a separate method for it. Now that you don't fix it yet, you just extract that method and you write unit tests for it for how it is expected to behave. And then of course those tests will fail because that's not how it actually behaves. Then you go ahead and fix it. So extract, write unit test, fix it, and then once you fix it, obviously the test will pass, and then you just need to call it from the big method. So how do you decide where to split? Because you can do that iteratively. You can extract one part, then another, until all of your huge method is now split into tiny methods and probably a lot fewer lines of code because you end up reusing logic elsewhere. You end up calling the same method multiple times because there's bound to be some repetition in those 800 lines. So what you do is you can spot logical groups, and they're usually always the same. You have a block of code and you have a comment explaining what the block does, because right after 800 lines you need to find where stuff is happening. So short blocks, then a comment on top, and a white space, an empty line between the blocks. That's usually how it goes, or 2 lines, just to distinguish that. There are your methods. There they are. So let's think back to the long method I showed you. What it was really doing is it had 3 major parts to it. It had the part where it converts a CSV to array of conferences. So what we're trying to achieve here is grab a CSV and then be able to plot conferences on a map. So you convert a CSV to array, then based on the location, so if you have an address for where the conference is held, you get the coordinates for that from Google, for example. And then you save that to a database. And then sometime later you can put this, based on the coordinates, you can put them on a map or do a radius search to say, hey, show me conferences within like a 4-hour drive or something, somewhere I can get. So these are the comments on top of the code blocks. And the way you extract it is you have your own method with that code block and you call it from the other method. Yeah. And you can do that for all the blocks also. As you have time, you can start refactoring other parts, or eventually, you'll find other bugs in that method, and you'll just keep extracting things one by one. But the thing is now that those new methods, they have unit tests. So you are slowly removing technical debt, increasing code coverage, maybe improving the structure of the code inside those methods, reusing them in the end. But how do you call these methods? Like, what would be the method names? Oh, probably the same as the comments, because the comment says what it does most of the time. And that's what the name of a method should be, right? The name of the method would be, obviously you standardize it somehow. You say get conferences from CSV, and then get location coordinates. So you pass a location, you get coordinates out of it, and then you save the conference. So you would put that array in there, and it's going to save the conference. And there you go. Now you have successfully refactored a long method. Obviously, 800 lines are a bit tougher. Here's another example of a big rewrite. So I was hired specifically to create a strategy on how to do a progressive rewrite of an application. They were stuck with ASP Classic, which has been discontinued for over a decade. So like not even security patches, it's dead. Okay, so there's ASP.NET, which is a new thing. ASP Classic is over. And they wanted to move it to PHP 5.6 because in Montreal it's quite easy to find PHP 5.6 developers. ASP Classic, not really. I think those people were the last in the city to use that, just because they were stuck with the product, you know, the project. So at the time it was 15 years old. Now it's nearly 20 years, I think, that code base. It was a long time ago. So the language no longer supported, and it's like this huge ERP with lots of code, not something you can just switch overnight. It would take years to rewrite that code. They definitely spent more than 17 years writing it. So the solution was to rewrite page by page to Symfony, like one page at a time. Mod rewrite for concerned pages, you will see me use that approach a lot. It's one of my favorites, especially when moving from one language to another, where you cannot really inject a module easily into an existing code base where the languages mismatch. Like the effort to try and connect things is too much. Because really, well, before that, what we did is we wrote a session adapter in both applications. Because the way ASP works, ASP Classic, is that the sessions, the user session, is not stored in a database. It was stored, not even in the file, it was stored in some secret compartment inside IIS, which is not accessible to other languages. So PHP could not go and grab that session. So what we had to do is write in ASP, write a little adapter that would send that session data to the database, and of course then the PHP can read it from the database. So it was actually pretty straightforward. And the good thing, they already had a wrapper around all the session storage, so they just had to go and write just, I don't know, 20 lines of code, and it was done. And the cool thing about having a page in any language is that HTTP requests are sort of units when you think about them, right? You have input. What are the inputs? The URL itself. You have stuff in the headers, maybe things in the cookies, which you also pass through the headers. Pretty much it. And then the database, everything else is shared. So whichever language you write it in, it's always going to be, you know, the input and the output. The output is what you see on the screen, whatever it's stored in a database, whatever it put in the session, or wrote to some other, you know, external place. But it's all the same. It's input and output, and you can test that. So in PHP we have Guzzle, or you can use curl or any other similar client. It was actually much simpler than they thought. What we did to assert that when we rewrite page by page, it's actually correct. What we did is we allowed both applications to run simultaneously. So in the test mode, we prepared an HTTP request and then sent it to the ASP page and grabbed the output. We store the response. Then we make the exact same request to its PHP counterpart that we just wrote, and we make sure that the responses are the same. Obviously, we check, you know, how many records it wrote to the database, things like that, any other type of output that's not directly to the browser. We compare those responses, and if they're the same, then it's done. Obviously, when you do that, people say, well, but the HTML is all crappy, you know, it's not going to be the same. There are ways to standardize things to be able to compare them, you know, at least the spacing. But of course, you're going to have to inherit some of the ugliness of the HTML that was written before it. But the good thing is, once you finish rewriting all the pages, then you can change the design, because you already know that it does what you want it to do, and then you can change the HTML to be cleaner, you know, like do another pass to clean things up. And tests are really important, and if you write tests before you do any code changes, you really you're going to have a much better time dealing with legacy, or any code for that matter. And this is a poem I wrote many years ago. Have some more on my blog if you want. So before you code, you better test so that on weekends you may rest, because, pretty straightforward. Yeah, just go to my blog. There's a couple more there. And yeah, so sorry, you wanted to take a picture? Go ahead. All right. So testing static methods, some people talk about that in PHP. It's complicated. There are tools for everything now. No matter language, there are tools, so nothing is really complicated anymore. So there is no such thing as untestable code. And there's another speaker who spoke many years ago. He's from Germany. And he talked about testing some really untestable code. And he found interesting tricks that, like, swap which file gets loaded for testing purposes. So even the worst code in the world is testable in theory. You just need to find a way to do that. But also, if you go overly zealous about testing, you're going to have a hard time. So just test things that make sense. And once you have clean code, then you can increase coverage because now it's in a testable state. But don't spend too much time testing something that you're going to put an axe to it and just take out. You're going to gut that code. So just mostly acceptance tests, some of the higher level tests, because unit tests make no sense, because once you refactor it, those units will no longer exist. You're going to take away those classes, you're going to take away those methods. So there's no, personally, I find no point in doing that. So some of the higher level tests are much easier to write in that case. And if you're stuck for any reason, you can bounce ideas. So you are now at a conference, and there are a lot of new people that you haven't met before. Talk about your specific cases. Oh, here we have this problem. Not sure how to fix that. When you do it with people inside your own organization, what happens is that everybody has some sort of bias, and they have this tunnel vision. We're trying to get there, therefore we're not looking at stuff on the side. You don't really think outside the box after a while, no matter how much you want to. Most of the time it's hard. So talk to new people, because then they might propose something that's very simple and silly that you have never thought about, because you are always focused on I need to get there, and everything else is an obstacle to getting there. And you're not thinking that, well, you can actually take a completely different approach and still achieve the same goal. Because people get stuck on the solution, not on the goal of, not what they're trying to achieve. Look at whether it has been done before. There is a lot of stuff on Stack Overflow nowadays. Not all of it is great, but there are people who have tried many things. There are blog posts out there about people who have experienced all sorts of problems. There are a lot more developers now than there were 15 years ago, especially in the web. So you can find a lot. There are a lot of resources online. There are books you can read. As I said, I bought a book about refactoring, and I saw all these things that I wish I had known, 12 years ago. So look whether it has been done before, and not just in programming. You have to talk to people from different backgrounds, because sometimes the answer may come from the most interesting places. You can talk to somebody who studies solar flares and stuff, and they can talk about something you're like, oh, I can see how I can apply that to this other problem that I have. Or it may be a cook or a gardener, nothing to do with science, but they found a solution that you can replicate for yourself in your own legacy code. So just talk to anyone. Just exchange ideas, try to learn as much as possible about all the things. And also, you should try different approaches. So if you are able to not have this tunnel vision, try different approaches, benchmarks, proof of concept. Before dismissing something as being too hard, make a proof of concept. See whether it's going to work. So one of the proof of concepts we did was that ASP classic DB session adapter. We thought it was going to, or rather they thought it was going to be very difficult. I thought, well, maybe not. Let's see how ASP can handle it. And their ASP expert wrote this adapter, And he said, well, actually, I think this is more than feasible. It's very simple. So think about what you want to accomplish. Do a proof of concept to validate your theories. Some things, if you see it's not working very well, then maybe you should try something else. But yeah, proof of concept is going to be very useful in case of legacy refactoring, because if you're going into if you're going to put, I don't know, weeks of efforts into rewriting something, then might as well try something first and eliminate the work in case you know it's not going to pan out before you actually start doing the real work and then dig yourself too deep into the rabbit hole and realize, no, there's no getting out of this rabbit hole. So I often, my rule of thumb is, if I tried like maybe 5 different things and I see that there's no end to the obstacles, I start to think like, am I getting myself into a deep rabbit hole? And then I just back out and look at other possible solutions. So the main takeaways from this talk, I timed it to 45 minutes, but apparently it was 55. I'm going to just take more questions. So the takeaways from this talk is you need a strategy, okay? And like strategy, backups, you need to plan things before you do something because it's a big investment. If you touch something, you have to refactor it. If you start doing it like that, then you will refactor things much more quickly than if you take on large chunks. Like you fix a bug, you refactor, you don't realize it, but you already removed some of the technical debt. And by just fixing bugs, eventually you can take out all of it. And then once it's much cleaner, maybe you can rethink the architecture a bit, but you'll end up with so much less code that wouldn't be a problem anymore. So instead of taking 2 years, it would take maybe 3 months, and then it becomes feasible. And all that just by, working with the code, writing new things, fixing existing bugs. So you touch it or you refactor it. That's a good rule of thumb. Use known tools and methodologies. So there are books about refactoring that you can read. There are many ideas in there on how you can think more on the code level, how you can do things step by step. Like the methodology I showed you with design extraction, use that, it's very useful. So it's nothing new. People have been dealing with legacy code for a while. There are a lot of resources out there. Get inspiration from others. So we still have 2 days worth of conference. Talk to other people over lunch, over coffee, whatever. Grab as many ideas as you can. Refactoring seems like a complicated thing, but it does get easier. I mean, for me, I've been doing that, as I said, for about 12 or 13 years. I lost track. When I first started, I would look at the code and I just want to throw my computer away. Like, I want to burn it. It's scary. And most people, that's their reaction. But today, what makes people want to throw up, I just look at it and I just go, it's not too bad. Like, I developed a tolerance for it and I became less scared of that kind of code. So it does get easier as you get more experience with it, and you find ways where you look at something and it looks terrible, but you already know exactly how to fix it because you've been there. So refactoring does get easier, don't worry about it. And also remember that every problem has a solution. So it's a bit like that MacGyver, who always finds a way. Just put him in a situation, he looks around at the available tools, and he finds a solution. And that's how I've been living since I saw this show, is I always try to find a solution. I believe that the solution is out there, and therefore it is always out there. So I've been coding total for about 20 years, and I have never yet encountered a problem that I could not solve. So that should give you some confidence that there's always a solution. There's actually several, and you have to do some proof of concept, and you have to pick the best one. So it's not really a lack of solutions. It's just you need more imagination. You need to develop your creativity in order to achieve that. And an interesting resource, and I'm in no way affiliated, this book, I really enjoyed it. Refactoring, Improving the Design of Existing Code. So it doesn't talk about strategy. It's very close to the code. just shows different ways of just making clean code out of existing code. So it shows, one of the first things it shows is the method extraction approach, and you can find other approaches as well that teach you how to just make existing code better. And I will tweet the slides, and you can also check out my blog. So yeah, follow the slides, and I'm open to questions now. Yes?
Kind of strange question, but you mentioned you rewrote billing the module in 40 hours.
Yeah.
So I'm really interested how could have you done this so fast, and for what size of company it was, like how many customers they were billing, at least?
Well, the number of customers is not actually relevant because it's the size of the system.
Okay, but well, then maybe you could tell some details about
Yeah, okay. So the scale of that, it was a rather complex system. So it was for, there were different types of teleconferences. So it would bill, minutes based on where the person is, whether they called into this center or that center, so where they called in, is it toll-free, not toll-free, other international fees, there are different local, regional taxes, like for example, just for the states of, which state was it? I think it was for Massachusetts. So specifically in the state of Massachusetts, teleconference applications need to charge every line $1.25 per month. So we had to figure out what a line is in our domain, things like that. So there were a lot of exceptions. California has 500 different tax regions, just the state of California. We had to process a giant spreadsheet just to be able to calculate taxes for the state of California. And it was an international software. So yeah, it was crazy.
So was it for processing spreadsheets, this billing?
The system, the way it worked is that it would synchronize data about the calls daily from the application, the actual teleconferencing application.
It was not real time.
No, it wasn't real time. No, you have billing cycles, and it would just do like a big batch, and it would process that and apply all the business rules basically in order to calculate that. Banks use a similar approach, where they synchronize data and they just apply all of the business rules one by one. So that's how we did it. The way it was implemented initially did not quite reflect how the software worked. As I said, it was just doing a lot of voodoo with SQL that didn't really make any sense. There were a lot of mistakes introduced there because it was poorly implemented. So yeah, the 40 hours was just the coding part. There was a part, analyzing before that, validating, the design extraction, validating everything with the client, a couple of back and forth. But once the plan is ready, just coding it was actually really simple because we could. It was the.
So you wrote only the processing model of it. That's not you reuse the existing business logics, what they are.
Well, if you say business logic, I mean all the code was written from scratch. He would just plug into those external services that would feed the data. It would plug into the database where it would have to output the result. And yeah. I mean, yeah, it's fast because the coding part is never really the complicated part. It's all the planning and everything, but even that took maybe 20 hours total, so about 60 hours. I mean, it looks like a big effort, but if you find a place where you can segment, and there's another book that I was I don't know, there's a mouse? I don't know. I hear screams. There's another book I was recommended, I haven't read yet, but it talks about seams, basically where you can cut your application. So you have to find a way not to rewrite everything, because that's not the point. Just like, here's the broken part you want to fix. Find a way to constrain it to the smallest, surface possible. right? So that you can say, okay, we can cut here. This is where we will integrate the new system. Cut here. This is where the So this is where the integration starts. This is where it ends. Constrain it as much as possible. So all the data that's being fed to it, that's the input. That's where we'll cut it. And storing to the database, that's another part. Sending the invoices, we already have a system. We don't have to rewrite that part because that part works. It doesn't have any errors. I mean, it's not clean, but we did not have to worry about that. What we needed was getting data in and getting the right numbers out. And the difference in billing really showed. It was like 15% more. So they just got a 15% increase in revenue. Well, revenue that was owed to them already by just rewriting one module. That helps?
No.
Ideas?
They gave some kind of idea, but still, it's hard for me to evaluate, this theory, but as myself, I work a lot with Duplication, so it's pretty much unbelievable. Such a short time.
Yeah.
With teams of tens and more people.
Oh, you have my Twitter. Talk to me.
The main takeaway was to talk to new people, right? So,
yeah. You can talk to me, then you can talk to others. Just shameless plug. Other questions? Sorry, 1 and 2.
About testing legacy code for PHP, what's the best framework you can start testing legacy code?
Yeah. What I like, if I'm going to do something like method extraction, where I can go with unit tests, then I use PHP unit. If I'm going to test behavior, like API endpoints, things like that, I'm going with Behat. And sometimes I would even write, between PHP unit and Selenium to write, end-to-end tests. Those are harder to maintain, so I try not to do too many of those. But yeah, it's something we can do if you need to test things like JavaScript. But if the application doesn't have much JavaScript, you can just do everything with Behat. Yeah. And there was a question here?
yeah, I want to ask if you, let's say, have a big project and you want to write module by module, how do you usually analyze it? The whole project at once, or only the scope of the part which you intend to detect from? What is the best strategy?
Okay, well, I sense that there are 2 questions here. Oh, and sorry for the camera, there's no microphone. So the question was, how do you determine where to cut things? How do you analyze, the entire software, or just the part that you want to change? Usually, for the analysis, I can just constrain myself to what's the part that I'm changing, and which processes depend on that part. So if the data that this part produces is consumed by other areas, I need to make sure that they have the data in the correct format. So obviously I'm going to have to make sure that I'm still dumping the data to the database in a way that the other parts can read it. But yeah, the analysis is usually constrained to the module that I'm doing. So if I do design extraction, just of the part that I'm changing. Now, how do I determine which parts I'm going to work on first? I usually look at how many dependencies does this have? Obviously, the size of the code base or the projected size of the end code base, because sometimes the original can be 10 times larger than what it can be. It can be written like in 1/10 of the lines. But yeah, lines of code is not actually a very good metric. Go more with complexity, how much stuff do I need to understand, whether the client actually knows how it's supposed to work, because sometimes things just disappear, The code base gets purchased from someone and nobody's even sure what's happening there. But they do know maybe how it's supposed to work. So yeah, go with the stuff that has the most business value in general. So a billing module that's, always 15% under, or we didn't know how much under we were because we never had the proper calculations done, but it seemed to be doing a lot of errors. So we're like, let's start with billing. It seems to be like pretty much the center of the application, the most important part. And it was a good call because then that financed the refactoring of other parts. So when we went into the multi-step sign-up that was having some bugs, we were able to rewrite that as well using the money saved from, or rather the extra money produced by the billing system. Yeah, so just go with either highest value and least dependencies. And as you rewrite more and more parts, you can decouple things, so dependencies are easier, and eventually you can take on any part that makes sense.
So the hardest part is to understand how it's working and how it's supposed to work. So for which you go first? You try to understand how it works, or you try to consult with people who can explain how it's supposed to work?
Well, it depends for which purpose, though. Like if you don't have any bugs in a certain area, then you don't even care how it's supposed. I mean, if people say, yeah, it works like it's supposed to. I know it's not clean, but it works like it's supposed to. Then you don't even need to care about that part. What we do care about is when somebody says, this is not working the way it's supposed to. We need to fix that. Okay, well, let's see. How do you want it to work? Okay, you get a rough idea. You start analyzing the code. You do the design extraction. So you start with how it's working. What is it doing? What is it trying to do? What do we want it to do? And then, yeah, so the design extraction pretty much gives you that answer. Does that help? Yeah, you just need to apply it a few times. Like, just theoretically, it's not very obvious to grasp. But once you follow the steps, it becomes pretty obvious. Yeah, just think of the updated design as your end result. Like, sorry, not the end result. The updated design is new specs for an entirely new project. And I believe we're out of time. Yeah, thank you very much.